Welcome guys to the best maths channel once again. So you're on Busy Made It Easy channel, the best maths channel in the world. Yes, this is where mathematics becomes fun for even someone who doesn't like mathematics. Yes, those who have kept following my lessons will know, and I've received so many testimonies that the channel is really helping. So if today is your first time, don't forget to hit the subscribe button and also like and comment your difficult topic, and it's going to be treated here. Today is the fourth lesson on the number basis series, and today we are going to talk about how to add and subtract numbers in number bases other than base 10. Yes, other than base 10. Now, why am I saying other than base 10? I've told you all numbers are written in the decimal base. And now let's come here. Let's say I have 40, then I have minus, let's say 2, 5. In a normal subtraction, I can't subtract 5 from 0 until I borrow. And me borrowing here, coming here, is what? The one I'm borrowing here, they will say here is what? 10. Why is it 10? The 10 because the number is in decimal basis. That is why when we borrow, we say it is 10. We have borrowed 10. That is the concept behind that. So 5 from 10 will give me 5. Then here has been left with what? 3. Then you subtract, then you get your 1. That is any number that is not in base 10. And any number that is not having a base is in base 10. That is the reason why when you borrow, when you are working with this, you say it's 10. And when I have a number like maybe 0.1, you said it's 1 on 10, the decimal base. So if I have 2.46, I can write it 246 over 100. The decimal in tens, 10 raised to the power to 100. Well, this one is 2. So what we have to understand is that addition and subtraction of numbers other than base 10. When you are working with base 2 and you have borrowed 2. When you're working in base 7 and you have borrowed 7. That's what you need to understand. And I've explained earlier that when you are working in base 8, the answers you expect should be from 0 to 7. If you are working in base 9, you expect numbers from 0 to 8. So if you get 9, when you are working with 9, you are wrong. That is the simple principle and concept you need to understand. You can't solve question in base 9 and get 9. It is not accepted anywhere. Yes, so this is the basic tricks. Every subject has a trick. Every principle, there are tricks inside. And these are the simple tricks I'm teaching, and you will not get it anywhere than say on Busy Made It Easy channel. So if you're working with base 3, now you know we need answers from 0 to 2. And if you're working in base 2, you need answers 0 and 1. The binary base is normally used in computing, the 0 and the 1. So most of the switches we use in our homes, you see the 0 and 1. 0 means off and 1 means on. So in the computing, we normally use the decimal. We use the zeros and the ones a lot. So somebody might ask, we learned this in school, we don't know what is this or math. All the concepts in math, all the lessons in math are very practical and applicable. So if you've not found yourself on the field, you might think math is very useless, but it's part of us. In our daily life, math is with us. Everything we do involves calculation. Yes, so we are quickly going to take our first question and see how the addition and subtraction is done on this time. So as our first question is posted on the screen, we have to evaluate 11001 base 2 plus 10111 base 2. So we are going to evaluate this. And in my previous video, I explained that in normal basis, the remainders are kept as the answers. The same principle applies here. So in our normal addition, we write the numbers vertically when we are adding. 1 0 1 1 0 0 1 base 2. Then we have 1 0, 1, 1, 1. So we are going to add it. We'll pay attention to this. You know, in my example that I gave, so when you are subtracting and when you borrow, because this is a decimal base, the number you have borrowed is 10. So it's added to this one. So when you borrow here, you have the 10, then 5. Here has left a 3. You subtract, then you get 1. But let's assume we have 27 plus, let's say, 13. When you add this and you get 0, you get remainder what? 1. That will give me 40. When you are sending the remainder forward, don't say that it is in base 2, so it is 2 you are sending forward. No, that one doesn't work like that. In the decimal number, when we borrow, it's in 10 because we are working with the decimal base. So you have to be very careful when you are borrowing. But when there's a remainder, you are carrying it forward. If it is 1, it is still 1. If it is 2, it is still 2. That is what you need to understand. Yes. So if that one is established, then we can move on. And I've explained to you, we are working in base 2. So the answers we are expecting should be between 0 and 1. We don't need to get 2 or more in this thing we are coming to do. Yes, that is why even the answers were given. So you can't even see 1, 2, 1, 2 in base 2 again. No. Yes, so we are going to add. Now pay attention. 1 plus 1 is 2. We are working with base 2. And 2 is not needed in base 2. So we know how to divide. Now, you have to use the division. So you do your calculation somewhere. 2 divided by 2 will be what? 1. Remainder what? 0. 2 divided by 2 is 1. Remainder 0. Or you can say 2 divided by 2 is 1. You bring the 1 forward, then remainder 0. It's like the successive repetition method. That's what you need to understand. 1 plus 1 is 2. We don't need 2 in base 2. So 2 divided by 2 is 1. Send it forward, then remainder 0. That is what we keep as the answer. Yes, now let's come here. 1 plus 0 plus that one 2 will give us 2. 2 is not accepted when we are working with base 2. The same way, 2 divided by 2 is 1. Remainder 0 again. Here, since here is 2, you still get 1. Remainder 0 again. Here is 2 again. Here is 2. So you get 1. Remainder what? 0 again. But here 1 plus 1 plus 1 is what? 3. Now 3 divided by 2. 3. So 2 divide 3 how many times? 1. Remainder what? 1. Yes, 2 divide 3. 1. You bring it forward, then remainder 1. Yes, we keep the remainder as answers. Since there's no number here, so the 1 is accepted, so we write the 1 back. So this will become our answer in base 2. Yes, so therefore, the 1, 1, 0, 0, 1 base 2 plus 1, 0, 1, 1, 1 base 2. Let me erase this. Will be equal to 1, 1, 0, 0, 0, 0 base 2 as our final answer. And I've told you, when you get 2 in your answers, you should know that you are wrong. Yes, you should know you are wrong. So the final answer is 1, 1, 0, 0, 0, 0 base 2 as our answer. So let's take the next question. So the second question says we have to evaluate 2, 3, 4 base 5 minus 1, 4, 1 base 5. So 2, 3, 4 base 5 minus 1, 4, 1 base 5. We are going to subtract. Yes, we are going to subtract. So 1 from 4 is 3. 1 from 4 is 3. Yes, 1 from 4 is 3. So now we need to subtract. We can subtract 4 from 3. So we need to borrow. So we are going to borrow 1. And the one we are going to borrow has a power of what? 5. Has a value of 5 because we are dealing base 5. So this will give us 8. Yes, this will give us 8. Now, 4 from 8. 4 from 8 will give us 4. And 4 is accepted in base 5. 4 is accepted in base 5. Now you need to be careful. Here has left with what? 1. We have borrowed 1 here already. Here has left with 1. So 1 from 1 is 0. So 043 will be our answer, which is the same as 43 or 43. So therefore, we can conclude by saying that 2, 3, 4 base 5 minus 1, 4, 1 base 5 will give us 4, 3 base 5. You can add the 0 to it. If you add the 0 to it, it doesn't add any value to it. It doesn't add any value to the number. So the final answer to this is 4, 3 base 5. Take note when you are borrowing. In base 5, when you borrow, you have borrowed 5. In base 6, when you borrow, you have borrowed 6. So let's take the next question. So this question, we have to perform the operation in base 6. Yes, so we have 141 base 6 plus 233 base 6 minus 102 base 6. So addition, when you see addition first, addition and subtraction, I've told you, you use the board mass principle. So in board mass, normally when you see an operation like this, addition comes before subtraction. So let's do the addition first. So we have 141 base 6. Let's add. Then 2, 3, 3 base 6. And in base 6, since we are adding, the numbers we are expecting, we know should be from 0 to 5. So we don't get 6 and above in base 6. That's what we need to understand. Now 1 plus 3 is 4. 4 is accepted. Then 3 plus 4 is 7. 7 is not accepted in base 6. So now 6 can divide 7. How many times? 1. Remainder 1. Or if you are confused, or if you be confused, use the table. 6 can go into 7, 1 remainder 1. So 1, you send it forward, and remainder 1. The remainders are kept at the answers. Now we have 1 here plus 1, which is 2. 2 plus which is 4. Is 4 accepted in base 6? Yes. So this one has given us 4, 1, 4, base 6. So on the addition. Now let's subtract our 102 from it. So minus 102, or in base 6. Can we subtract 2 from 4? Yes. So it will give us 2. Now 0 from 1 is the same as 1. The 1 from 4 is the same as is 3. So 1 from 4 is 3. So in base 6. So this is how we solve it. So if you solve in base 6 and you are getting answers below 6, at least it should tell you something that yes, you are on track. But if you get 6 and above in base 6, you should know you are wrong. So therefore, we have 141 base 6 plus 233 base 6 minus 102 base 6 will give us 312 base 6. So this will be our final answer to this. So just it's a normal addition, but when you are borrowing is when you need to be careful. And the normal range you need to understand when you are working with the other bits. So let's take the next question on this. So we have to evaluate 3001 base 5, 3 base 5. These are 4 digits, 3 digits, and 4 digits. So to make it easier, or to be at the safer side, I can arrange all the 4s first, then I can bring the 3 figure down. Or yes, still, I can just solve them as they appear. So 3001. Alright, now let me even open the numbers. 3001 base 5. plus 4, 4, 4 base 5, then plus 2, 3, 3, 3 in base 5. Now we are going to add in base 5. And you know the answers we expect should be from 0 to 4. If you get 5 in base 5, we are off track. Now 1 plus 4 is 5. 5 plus 3 is 8. Now 5 divided by 8 will be what? 1. Bring the 1 forward. Remember what? 3. If you are using the table, 8, 5. 5 can divide 8, 1. Remember 3. So the reminders are kept as the answers. That's what you need to understand. Now I've brought the 1 forward. 1 plus 0 is 1. Plus 4 is 5. Plus 3. 8 again. So 5 divided by 8 is 1. Remember 3. Again. Now 5, 8 once again. So 1 remainder 3. Now I have 1 plus 3, which is 4. 4 plus 2, which is 6. Now 6 divided by 5 will also give me 1, remainder 1. Now I have 1 here, nothing here, so I'll just write it as my final answer. So I'll have 1, 1, 3, 3, 3, base 5 as my answer. So you saw how I added it in my previous video, and it does the same thing I've done here. Yes, so you add, and the answer you get, if it is more than the base, you divide. If you are confused, use the table, and remember we keep the reminders as the what? The answers. Yes, we keep the reminders as the answers. So we can conclude by saying 3, 0, 0, 1 base 5 plus 4, 4, 4 base 5 plus 2, 3, 3, 3 base 5 will give us 1, 1, 3, 3, 3 base 5 as our final answer. Yes, so this is how it is also solved. Let's take our next question on this. So we have to evaluate this one to 2, 3, 2, 1 base 4 minus 1, 3, 3, 2 base 4. So we have 2, 3, 2, 1 base 4 minus 1, 3, 3, 2 base 4. Now we are going to subtract. And we are subtracting in base what? Base 4. Now, can we subtract 2 from 1? No, we need to borrow 1 from here. And the one we are going to borrow from here, because it's in base 4, it is 4 we have borrowed. So when you add the 4 to this one, to give us what? 5. Now, 2 from 5 will give us 3. As simple as that. We need to be careful when we are borrowing. But when there's a reminder and we carry it forward, it's the same figure. Now, remember, here has left with 1. We have borrowed here. Now, we are going to borrow 1 from here because we can't subtract 3 from 1. So, the one we are going to borrow from here to will be what? 5. So, 3 from 5 will also give us 2. Yes, will also give us 2. If you understand these tricks, any number in number base, you can be able to add or subtract. Yes. So, now here has left with 2. Here has left with 2. We can't subtract 3 from 2. So we borrow 1 from here, which is 4. 4 to the 2 will be 6. And 3 from the 6 will also give us 3. Now we borrowed 1 here. Here has left with 1. 1 from 1 is what? 0. The answer in B is what? 4. Simple as that. Yes. And this can only be simplified on this channel. So if today is your first time, you can hit the subscribe button. You like, you share, then you comment. So therefore, 2, 3, 2, 1 base 4 minus 1, 3, 3, 2 base 4 will give us 3, 2, 3 base 4. You can bring the 0 if you want to, because if you see 0, 8 is the same as 8. So when 0 is beginning a number, we see it as insignificant. So this is how we solve this. So let's take the next question, which involves finding missing numbers. So the question posted says that we should find the missing number in base 6. So we have 452 minus a certain number giving us 254 in base 6. So how do we find the missing number? Now let's look at this. Let's use the common principle here. Let's have 8 and they say minus a certain number is 6. 8 minus a certain number is 6. How do I get the answer? In simple put, I'll just subtract the answer from 8. So which will give me 8 minus 6, which will give me what? 2. So 2 replace this one to give me what? The answer. We are going to use, that's the same principle we are going to use in number base. But make sure you remember the subtraction concept and the number range we need. So this one means that we are going to subtract this answer from the 452 to get our what? Our missing number. As simple as that. So this is what is going to give us 452. Let me write the base so that to remind me, minus 254 in base 6. Now I'm going to subtract. I can't subtract 4 from 2. So I need to borrow. And if I borrow 1 here, which is 6, which will give me 8. So 4 from 8 will give me what? 4. Maybe add the base 6. Yes. 4 from this one is. So now here I was left with what? 4. I'm borrowing 1 from here to it because I can't subtract the 5 from it. When I add the 1 here, which is a 6, to the 4, it will be 10. Now 5 from 10 will give me 5. And 5 is accepted in base 6. So I write that. Now here I was left with what? 3. When you borrow, remember. So 2 from 3 is going to give me 1. So the final answer is what? 154 base 6. How do we know this answer is correct? Now let's look at something. So let me replace it. 452 minus 154 base 6 base 6. The answer I've gotten. Let me see. Math, you need to prove your answer. So look here. I can't subtract 4 from 2. So I'll borrow 1 here. Here will be what? 8. So 4 from 8 to give me what? 4 in base 6. Here I was left with what? Here I was left with 4. 1 here will be 10. So this will be what? 5. Now here I was left with what? 3. 1 from 3 is what? Is 2. Am I correct? Yes. So you see. So whichever way you do it, your answer should be correct. You should be able to prove your answer. Somebody will say, since there's no time, how can I prove my answer? You should know. That's why you need to work fast. You work with time so you'll be able to prove your answer. So when the question looks like this, just subtract the answer from the top number. And when it comes to the addition onto, I'll teach you how it is done. So let's quickly take the next question on this. So this question says the following addition was done in base 4. Find the missing numbers. So this is an addition. And let's do this. So that we apply the knowledge here. So if we have 21 plus a certain number plus. So now let's do this. So 21 plus a missing number plus 10. Let's say it's giving us, let's say 71. Yes. Now how do we get the missing number here? How do we get the missing number? We have to add these two. 21 and which will give us 31. Then we subtract it from the what? The answer here. Unlike the addition on that, if I have 6, a number, the subtraction on that minus a number gives me maybe 10. That one, how do we get the missing number? The subtraction on that we did. To get the missing number, you have to come and subtract this from this. Then you get the answer. Yes. But with this one, what you have to do is that you add. Then you come and subtract the answer you get here from the one down here. But this one, we subtract this answer from this one to get our answer. So that's the difference between the addition and subtraction. But remember, they said the question was performed in base 4. So if I rewrite the question, 3101 base 4. Then I have 2, 1, 3 base 4, 1, 0. Let me arrange it for 1, 0, 3, 0. So I have 1. Let me start from here. Then I have the 0, 1 in base 4. This is to remind me. So I have to add these two in base 4. So 3, 1, 0, 1 base 4 plus 2, 1, 3 base 4. Now, base 4, we know the number range from 0 to what? 3. So 1 plus 3 is 4. We don't need 4 in base 4. 4 divided by 4 is what? 1. Remainder 0. Yes. Then 1 plus 1 is 2. It's accepted in base 2. You write it. This one is 3. It's accepted. Then we have our 3 here. So this is the answer we've gotten here in base 4. So we've gotten this answer. So this answer here, we are going to subtract it from the answer here. So we have 1, 0, 3, 0, 1 base 4 minus 3, 3, 2, 0, 2 in base 4. So 0 from 1 is 1. So let me write the base 4. 2 from 0 is not possible. You borrow 1 here, for which is in base 4, which is 4. So here will give us 2. So let me repeat. We can't subtract 2 from 0. You borrow 1 here in base 4. So here is 4. 2 from 4 is 2. Now here is left with 2. Here is left with 2. You can't subtract 3 from what? From 2. The number here 2 is 0. So what are we supposed to do? We are supposed to borrow 1 here. So that here will be base 4. Here is 4. So we can take 1 from here and come and add it to the 2 here, making what? 6. So 3 from 6 will give me what? 3. Don't forget, here was 4 because we borrow 1 here, and here is left with what? 3. So 3 from 3 to is what? 0. Do you have any number here? No, because we borrowed this one here and we carried it here. So the number here has finished. So here to give us what? 0. This is what you need to understand. So I intentionally brought this question so that you understand the dynamics in the setting of the questions. Yes, all these are past questions I've selected. And I'm simplifying them here so that when you see any question, you'll be able to solve it. So we borrowed here, we couldn't subtract. So we couldn't subtract this from the 2. That we borrowed 1 here. So 2. Here 2 is 0. So we borrow 1 here. Here is 4. We carry 1 here to the 2, which is 4, 6. So here has left with 3. 3 from 2 is 0. Then here 2 has finished. So therefore, 310. 3101 plus the missing number plus the 213. Yes. So let me put the answer I've gotten here. So 321. Then plus the 213 will be 10301. So the answer I got was this one. So this was the missing number. So the first one, I proved it. So you can also put it back and add and see if you get the answer. So let's take a very final question. So we have to find the missing number in the following in base 5. This is in base 5. So let's add, then we subtract it from the answer since this is addition. So I'm going to 241 base 5 plus 132 base 5. So 1 plus 2 is 3. Is accepted in base 5. Then 3 plus 4 is 7. 7 is not accepted in base 5. So 5 divided by 7 will be 1. Remainder 2. Yes, 1 remainder 2. So 1 plus 2, 3 plus 1 is 4. And 4 is accepted in base 5. So this is the first step. You add this. Then we are going to subtract the answer from this. So we have 4, 4, 2 base 5 minus 4, 2, 3 base 5. Now let's look here. We can't subtract 3 from 2. We borrow 1 here, and the 1 is 5. So 5 plus 2 is 7. So 3 from 7 will give me 4 in base 5. Then here has left it 3. 2 from 3 is 1. Yes, then 4 from 4, 2 is 0. So this is my final answer. Yes, and now, since this is our very final answer, let me put it back and prove to see if our answer is correct. So we have 2, 4, 1. Now let me put this one there. 0, 1, 4, 1, 3, 2. In base 5. So 1 plus 4 is 5 plus 2 is 7. 7 is not accepted in base 5. So 5 divided by 7 is 1. Remainder 2. Now 1 plus 4, 5, 6, 9. 9 divided by 5 will be 1 remainder 4. Yes, 1 remainder 4. Now 1 plus 2 is 3. 3 plus 0 is 3. Plus 1, 4. Is 4 accepted in base 5? Yes. So 4 is accepted in base 5. So when you bring it here, so we see that our final answer is correct. So therefore, the missing number is 1, 4 base 5. So this is the last question on this, and it can only be simplified on this channel. Yes, it can only be simplified on this channel. So this is the end of the addition, subtraction, and finding the missing numbers on normal basis. So if today is your first time seeing this channel, don't forget to subscribe, like, and share for other people or for others to have a benefit of it. Watch out for the next lesson, which is another tricky area, which is the multiplication of number bases and relations involving tables, and they are all going to be simplified. Don't forget to subscribe and recommend. There's a playlist for all lessons on the channel, and there are short videos which are past questions on the WASI and the BEC as well that you can also watch and learn. And this is where here for everyone. Until we meet again, say goodbye for now.